Hello, pre-calc people. Time for another great video. Best part about this video is no more trig identities after this. So on the test, it's 10 multiple choice questions. Two questions, two are simplify. And remember, they're multiple choice, so you're going to kind of know if you're in the ballpark or not. Question number 1 has a common term, otherwise known as a GCF, otherwise known as cosine squared. So we're going to take that out. And what's left when you divide by cosine squared is sine squared theta minus 1. Now remember, you'll get the formula sheet, that same formula sheet you've been getting. And on the formula sheet, it will say sine squared plus cosine squared equals 1. So if you were, and you should, subtract sine squared from both sides, then you get that cosine squared is equal to 1 minus sine squared. But that is not sine squared minus 1. So as you know, if you would like to switch the 1 and the sine squared, you must also make this cosine squared negative. So what we're going to do is take out that sine squared minus 1 and put in its spot negative cosine squared. And of course there's, this is theta. Of course there's still a cosine squared on the outside, and cosine squared is cosine to the 4th, and should be negative. Number 2 is a sum identity, because you can see the parentheses, you can see the plus sign. So you would do cosine first angle times cosine of that second angle. Now with cosine, you don't use the same sign. So since we're adding, this is going to be a minus. And then it goes sine of that first angle, sine of the second angle. Then you evaluate. If you can evaluate, you get rid of the word and the angle. So the cosine of 3 pi over 2 is 0. Cosine of x we don't know. The sine of 3 pi over 2 is negative 1, and the sine of x we do not know. So here we get 0. Two negatives make a positive. 0 plus the sine x means we get sine x. And of course, simplify, the directions mean get it down to a single word or some term that cannot be simplified, like cosine to the 4th, for example. Now this is a big deal. Number 3, it's just two things being added together. You're going to need a common denominator. Seems to be like a big issue. Common denominator. Get one. So we're going to switch the tangent to sine over cosine. Why? Because we can. And we should, because what else are you going to do with it? No identity can be used here. This fraction, of course, has nothing. Can't do anything with it. It's not part of any identities or anything. So our common denominator, like all common denominators, needs to represent all the different parts. Generally, the best way and easiest way to find a common denominator is just to multiply all of your denominators together. And when you have words like we do, it's probably the easiest. So I'm just going to multiply the two denominators together. The denominator is officially finished. It will remain that way until we simplify it a little bit. So the numerators need to catch up. So in order to make this one look like cosine times 1 plus sine, I've already multiplied it by 1 plus the sine of x. So now I need to make the denominator do that as well. So I've already done the numerator. That's already done. In the second fraction, I already multiplied the bottom by the cosine of x. So now I need to multiply the top by the cosine of x. So I'm going to put this first. Sine x times 1 plus sine x plus cosine times cosine is cosine squared x. Now be careful you don't start crossing stuff off, because the top isn't multiplication. The top is adding. So distribute first. My dear Aunt Sally told me that I should multiply first. So sine x plus sine squared x, and then plus the cosine squared x on top of the same denominator. Now, sine squared plus cosine squared, that's a 1. So my numerator is the sine of x plus 1, and my denominator is the cosine of x times 1 plus sine x. Now when you're adding, it doesn't matter if I say 1 plus sine or sine plus 1, they match. So the numerator just now has a 1 in it. So you can see now we are 1 over cosine, and 1 over cosine is the secant. Please follow the directions. Sum or difference identities. There are 2 questions like this. Number 6 is also a sum or difference identity questions, but there are 2 questions like this on the test. So you're going to take your number 195 and you're going to turn that into 2 angles on the unit circle. Please don't say 10 plus 185 because that's true, but it's not going to help you because it says exact value, which means you cannot have any decimals. No decimals. Exact value. No decimals. No decimals. So I'm going to turn my 195 into 45 plus 150. Because it ends in 5, I know I could probably use the 45. And the 150 was just left over. So this formula says sine of the first angle times cosine of the second angle. Now for sine we use the same. We're adding, we end up adding. Then we're going to do cosine of the first angle times the sine of the second angle. Remember A, B, first angle, second angle. So a lot of you are really pretty good at that. And then here's where things start to happen. Sometimes you leave the words in. Please don't leave the words in. The sine of 45 is out, and in its spot is what it's equal to. Cosine of 150. In the second quadrant, cosine is negative. That plus is from the formula. Cosine of 45 is radical 2 over 2. And the sine of 150 is positive because it's in that second quadrant. Now when you multiply straight across the top. So this is negative radical 6. Straight across the bottom, that's a 4. 2 times 2. Then here we get radical 2, and 2 times 2 again is a 4. As you can see, we have a common denominator. And when you have a common denominator, you write that once. And you simply work your way across the numerator. So this is negative radical 6 plus radical 2. No decimals. Number 5 is very specific and says use half-angle formulas. There is one problem like this on the test. It'll tell you half-angle identities. So the first thing you do is you take 67.5, you take your angle and you double it. This is going to give us 135 because 135 divided by 2 is equal to 67.5. So what we're really doing is we're finding the cosine of 135 over 2. Because if you look at the formula, you're supposed to put alpha in the formula. And alpha is the numerator, and our numerator is 135. So this is going to be square root 1 plus the cosine of 135 over 2. Take that word out. Also, pay very close attention to the fact that this is a giant radical sign and is around both the top and the bottom. So I'm going to separate that out. The numerator is 1 minus radical 2 over 2. Oh, hey, look, it's 2 more fractions I'm trying to subtract. I need a common denominator. Okay, so I'm going to turn my 1 into 2 over 2. Notice the pattern. I see a radical sign and then a smaller underneath there. We got to pay attention to that. Coming down here, I now have a common denominator and can combine these. But notice, it's still under the radical sign. So the numerator has a radical sign around it, and it's 2 minus radical 2 under it. This little denominator is the square root of 2, and underneath that we have the square root of 2. If you'd like to put that over 1, please do. So now we have the square root of 2 minus radical 2, and then these two are our denominator. There it is. And look, oh, there's no decimals. Now for number 6, this was very similar to the extra credit question on the quiz. So if you notice, it goes cosine, cosine, sine, sine. Cosine, cosine, sine, sine. That's the same thing as problem number 2. Cosine, cosine, sine, sine. All right, so problem number 2, was a cosine problem, so this is also going to be the cosine. And the pattern is first angle, second angle. Now with cosine, this is an addition problem, so that means this is a subtracting problem. Then all you have to do is do 2/3 minus 1/2. The pi is in there, and you can't change that, and you can't put that in the calculator because the calculator treats it like a decimal. So you really want to just do 2/3 minus 1/2. If you can't do that without the calculator, put it in the calculator. You'll get 1/6. Now we got to put the pi back in there. So this is really the cosine of pi over 6. Oh, A. For number 7, we are switching these identities to double angle identities. How do you know? Because it says 2 theta. There are 2 questions about double angle identities. There's only one on here, but there are 2 on the test. So we're looking for a place where sine is positive, so here and here, and cosine is negative. That's what that means. Oh, so it means we're over here. So we're in the second quadrant, and the sine, which is S equals opposite over hypotenuse, the sine is opposite over hypotenuse. And you have a choice of a lot of formulas there. You could use the formula with the sine squared in it. I'm not going to, of course. So I'm going to find this piece. X squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. So x squared equals 5. So this is a radical 5. Because I like the formula where you do cosine squared minus sine squared. So here the cosine is radical 5 over 3. I'm going to square that. And the sine, of course, is 2 over 3 squared. So this is 5/9 minus 4/9 equals a 1/9. You don't have to do that formula, but that is the answer. Solving. Everyone's favorite. One of these. None where you multiply the interval. Okay, so you will not be multiplying the interval. You will be doing a lot of factoring though. So let's just start with this one. Interval is in radians. Make the word on one side and the numbers on the other. So now we're going to divide by 4. So now we have sine squared x equals 1. When you take the square root, you should have 2 answers, always. So now we're looking for angles that have both a positive and a negative 1 for their sine. You can put that in the calculator. It does need to be in radians though. Pi over 2 and 3 pi over 2. Now number 9 we're changing. This, I forgot to change it. So the problem was supposed to be, and is now, cosine of 2x. That's a double angle formula. Minus the sine of x is equal to 0. Still in rate and degrees, but let's solve this problem. So because of the sine, you should pick the formula. That's 1 minus 2 sine squared, because there's already a sine in there. So cosine of 2x is coming out, and in its spot we're going to use from the paper 1 minus 2 sine squared. And then we still have a minus sign, still equal to 0. So you have a trinomial because you have a term squared, a plane term, and then a plane number. So I'm going to put this in the right order. Negative 2 sine squared x minus the sine of x plus 1 equals 0. I don't like to factor when my first number is negative, so I'm going to multiply everything by a negative 1. So this is going to be now 2 sine squared x plus sine x minus 1 equals 0. And we factor. So the only way to get a 2 sine squared x is to go 2 sine x sine x. The only way to get a 1 when you multiply is 1 times 1. Now, you need to figure out which is the positive one. We have one positive one and one negative one, and switching the signs means you get the wrong angles. So we're going to use the O and the I part of FOIL. O means outside, the two farthest away. And if you look at that, this turns into 2 sine x. Then the inside is right here. This is 1 sine x. The only way to get a total of 1 plus 1 is to make the 2 positive. So the 2 came from all the way on the outside. So that means this is the sign for the 2. This is the sign for the 1. So 2 sine x minus 1 equals 0. Sine of x equals 1/2. Sine is positive in the first 2 quadrants, 30 and 150. Over here we get the sine of x equals -1. We just did that. It was 3 pi over 2 in problem number 8, and now it's 270 degrees. Problems involving triangles. Excuse me. 2 of these. 2. One with a pic, one without. Picture, diagram. So for this problem, you can, and really this is going to be true in another problem here in a second, these are right angles. I know they're not marked, but they are right angles. Some of the things you can assume are right angles: buildings are perpendicular to the ground. Usually trees are, unless they're leaning. Buildings the same way, unless they're leaning. You can assume that people, if they're standing, are also forming a right angle with the ground. So for this one, we're assuming that our reference point and our reference line it would create a right angle. It only would make sense if you're surveying to control something. So that's the angle, that's the right angle. And now you have 2 right triangles. So in this right triangle, up here, 180 degrees in your right triangle, that makes this angle 55 degrees. And then you have another right triangle down here, another 180 degrees in the right triangle, which makes this 68 degrees. Then you have this straight line. These 3 angles, this is a 55, this is 68, and the 3 angles right here should add up to be 180. So 180 minus those 2 make this 57 degrees. So now we're looking for this. You have a side angle side situation, so that is law of cosines. So law of cosines, remember, if it starts with whatever side, it ends with the angle opposite it. So this is going to be x squared equals 148 squared plus 215 squared. Now that is not in a specific order. You can switch those two. Minus 2 times 148 times 215 times the cosine of 57. Now remember, when you put this in the calculator, you want to take the square root. You can either do that first or last, but make sure you take the square root and you get x equals 182.9, and this is in meters. I know the problem says show your work. There really isn't much work. It really is just writing down what you're using. So let's do one where we don't have a picture. So we're looking to find a height of a tree. Let's say here's the tree. So standing 8 feet from the tree and looking up. So remember, your angle of elevation is from straight out to up. Right in through here, straight out to up. So our straight out is the ground, and up, I know her eyes aren't on her feet, but we're going to not include the height or the space between her eyes and the ground. So we're not going to worry about that. It's not mentioned, so we can't include it. So from her feet eyes, when she when she looks up at the tree, this makes a 52-degree angle. Oh, where's the tree, you might say? I don't know. It's over here somewhere. So this is the tree. The tree apparently is leaning toward her. It's leaning toward her. So 2, this is her. And so the angle is 85 degrees with the ground. So here's my tree. Oh, that's not the top of the tree, I guess, but you get what I'm saying. So now we're looking for the height of the tree. 180 degrees in a triangle, which means our missing angle is 45. So now we can set up the law of sines. So I want to make sure I include the ones I know. So the sine of 45 over 8. Now I want to make sure I also use the part I'm looking for, and across from the x is the sine of 52. Make sure you're in degrees in your calculator and cross multiply, divide, and you get x equals 9.2 feet. This is not an inverse question. All right, so for number 12, we want to find out how wide this river is. And you can see we got a nice little triangle there with a little question mark. And this, yes, this is a right angle. But the problem is, in your right triangle, you have only one angle. And you can find the other angle, but you don't have any sides. You need a side. So we're going to be forced to start with the only triangle that has a side in it, and that's this big one with the 280. And in this triangle, you know that this is 48 and 52 degrees. And so that means this angle up here is 80. Now, it doesn't matter which side you find. You could find this side or this side. I'm right-handed, so I'm going to find this side. I don't know what that has to do with it, but, you know, I'm going with it. All right, so now I'm going to find that side of this big around the outside triangle. So the sine, all signs again, of 80 over 280 is equal to the sine of 48 over x. Now you could easily do the sine of 52 over x, but I'm on the right-hand side. So this right-hand side length is 211.3. Now, in order to find what the question is, there's my right angle again. There's my question mark in the problem. Maybe I shouldn't use x again, but this is the question mark. So this will be my width of the river. The number I just found is 211.3. This angle is still 52 degrees. This is a right triangle, which means I can use anything from SOHCAHTOA. So I have opposite, I have hypotenuse. That leads me to sine of 52 equals my missing width over 211.3. And in the calculator, you know you cross multiply. So 211.3 times the sine of 52. And like magic, the width of the river is 166.5 feet. Angle of depression is the exact same thing as angle of elevation. The problem with angle of depression is that it lives on the outside of the triangle, so it has a little bit of awkwardness to it. So if this is me. Hi everyone. And I'm not floating. I'm not. Just give me a minute. I'm standing on a cliff. All right. Down here is some object that I'm looking at. If I look straight out, that's my line of sight. Now, if I choose to look down at the object, this is an angle of depression. From my straight out line of sight to down to my little object, that is the angle of depression. So a lot of times you're going to have your triangle live right here. And so that's what I meant by the angle of depression, lives on the outside of the triangle. It actually can be drawn right here as well, because these are alternate interior angles. And so angle of depression and angle of elevation are congruent. So if you want to always draw it in the lower right-hand corner, because you're right-handed, or you want to draw it always in the lower left-handed corner, whatever works for you, but it's going to be the same. So take a look at number 13. We've got this blimp. It's hovering over a stadium. Altitude is always perpendicular to a ground. That's how airplanes work, everything. The altimeter just automatically finds a point perpendicular beneath it. So this is 125 meters. And that's your right angle. It is a right angle. So the pilot, who's down here, remember, he's not up here, he's down here. So he sees a tennis court. So this is what happens when the pilot looks straight out. And this is what happens when the pilot looks at the tennis court. Ooh. And the angle of depression is 8 degrees. It's a small angle, which means the 8 degrees can also be over here. Now it says to find the ground distance. Here's my tennis courts. This is my stadium. Now to find the ground distance, so the distance in a straight line on the ground, not floating in the air, on the ground, between the two stadium and tennis court locations. So this is opposite, this is adjacent. This looks like a tangent problem. Tangent of 8 equals 125 over x. Cross multiply. X tangent 8 equals 125. And so you're going to divide by the tangent of 8. And so x equals 889.4. And you're welcome for the little bonus lesson of me looking at an object from a cliff. I hope you enjoyed it. Bye.